All right, ladies and gentlemen, come away. Here we are, ladies and gentlemen. We are talking about dilations today. Yesterday was easy. All right, you had a Delta Math assignment. Maybe you got it done, maybe didn't. You can work on it today after if you have time. But get it done by this weekend. We have been talking about transformations, and we have done in the past sections translation, which slides your figure left, right, up, or down. We've done reflection, which flips your figure over a line or over an axis, okay? And we've done rotation, which takes your figure and rotates it. Eyes up here. Turn around, face front. All right. So all of these rotations, translation, reflection, rotation, these are called rigid motion transformations. And by rigid motion transformations, that means that the shape that we start with is the exact same shape as the figure we end up with. Right? We're all on board with that? Mm-hmm. Okay. So rigid motion transformations keep the figure the exact same size and shape. Well, today we're talking about dilations. Where have you heard the word dilation before? Eyes. Your pupils dilate. I mean, they get really, really big. They also dilate to contract and get really, really small. Okay. So that's what dilation means. We're going to take a figure and we're either going to make it really big or we're going to make it really small. And those are called scale factors. What are we scaling it up or scaling it down to? Okay. So we want to dilate the figure according to the given scale factor. Plot the image of figure ABCD after a dilation with scale factor 1/3. Scale factor 1/3. One of the sides has been plotted for you. Ladies and gentlemen, you should pay very close attention to the segment that they have given you for your figures. Your figures will be more complicated than these rectangles here. You'll notice they're giving us A prime and B prime, which comes from the top of our figure here, A and B. What we need to do is we are going to see here, how long is this segment AB?
It is 6.
6, okay. And to figure out the new side length, we multiply it by the scale factor. What is 6 times 1/3?
2.
2. It is. And so then you can see this new side length. What's its new side length? 2. Very good. All right. We're going to do the same thing all the way around. We have side BC here. How long is it? 3 spaces. 1, 2, 3. And what is 3 times 1/3?
1.
1. So we are going to go down one little bit there, and that is C prime, and connect those up. Here again, what about CD? How long is that? It's 6 times 1/3, which will become only 2. Well, we know that because we can easily just connect this figure. That's not hard. It also has a side length of 2. And this other side has a side length of 1 now. When we have a scale factor, all we have to do is multiply by that scale factor to give us our new figure. Very, very simple. So letter B here, plot the image with a scale factor of 2. Again, they gave me side CB, which is at the bottom here. How long is the original side CB? 5. 1, 2, 3, 4, 5. And we're going to multiply it by 2, which gives me a side length of 10. So this new side should be a length of 10, is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, it is. Okay, fantastic. What about this side CD? How long is that? 4, and we're going to multiply it by 2, and what should it become? 8. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, and there is point D prime. It is a length of 8. Okay. So all we have to do is take our side lengths and multiply them by the scale factor to get us our new side lengths. And of course, from there we can just connect these dots pretty easily because it's a rectangle. So there is A prime, B prime. All right. Ladies and gentlemen, is our starting figure, which I'm going to call the pre-image, is the pre-image congruent to the image? No, definitely not. What does congruent mean? The same exact shape, okay? They are not congruent. We have another word. They are not congruent, but they are similar. All right? We are going to talk more about this word similar. It's very cool. Lots of cool things happen when we have similar figures. Most notably, our sides are proportional by a scale factor, in this case, of 2. All right, example 2. Find the scale factor of the dilation. Is the dilation a reduction or an enlargement? For this first one, this first figure is the pre-image, and the right side is the image. And they actually tell us that in the directions in Delta Math. They're going to say that. So the first thing is the pre-image, and it becomes the thing to the right, which is the image. All right. So right off the bat, is it a reduction or an enlargement? Yeah, it is a reduction. And that's pretty easy to see because we can see that it's getting smaller. So visually, very easy to figure out if we have an enlargement or reduction. But we also need to find the scale factor. So to find the scale factor, all we need to do is find the ratio of the sides. Girls, quiet please. It is the image side length over the pre-image side length, corresponding sides. So my image side length is 15. What's its corresponding side length? Yep, that 40 right there. What is 15 over 40?
3 over 8.
3 over 8. How'd you get 3 over 8? You divided both by 5. Beautifully said, sir. You divided both by 5 and you got 3 over 8. That is the scale factor. Now, that scale factor is nice because not only can we figure out if that image is a reduction or an enlargement, but just looking at that scale factor, just looking at those numbers, is it going to be an enlargement or a reduction? Reduction, why? Because it's a fraction less than 1, all right? It's a reduction because 3/8 is less than 1. What's, how many eighths is 1?
8.
8/8. Right? 8/8 is 1. 3/8 is less than that, isn't it? So because this is less than 1, we know that it is a reduction as well. So we can tell 2 ways. All right. Letter B here, scale factor. What's our ratio going to be? 40 divided by 9. That doesn't reduce. Reduction or enlargement? L-A-R-G-E-M-E-N-T. Okay, enlargement. And again, we can see it, but this fraction, 40 over 9, is greater than 1. 9/9 would be 1, so 49 is a lot bigger than that. Okay? All right, questions on those? Is this easy or hard?
Easy.
Super. Every time I'm recording in this class. Okay. Bye. All right. Example 3. The figure is dilated by the given scale factor. Plot the resulting image. What does SF stand for? Scale factor. Nice. Okay. Yep. Scale factor. Now, so we have a scale factor. That's very easy. All we have to do is multiply by a scale factor. But I don't just have a figure with side lengths. Instead, we're actually on a coordinate grid, so we have coordinates. So, ladies and gentlemen, let us write down the coordinates. What are the coordinates for A? -2. -1. -1, thank you. B is?
0,
Good. C is? 2, -1. D is? 1, 1. E is?
1, 2.
1, 2. Very good. Now, again with notation, we are multiplying by 4 because that's our scale factor. We are going to do a dilation. Big capital D for dilation. And we are going to multiply the x coordinate by 4 and the y coordinate by 4. So we're just multiplying both coordinates by 4. So A prime becomes what? -8 and a -4. -2 times 4 is -8. -1 times 4 is -4. All right. B prime is going to become what? 0, -8. Good. All right. Go ahead and take a second and finish up C prime, D prime, E prime. And once you know the order of pairs, what are you going to do? Plot them.
That's a lot.
All right. What is C prime?
8, -4.
8, -4. D prime?
4, 4.
4, 4. E prime?
4, 8.
Good.
What do we say?
All right. Okay, so then I'm going to go ahead and plot my points. -8, -4. And you know, can you wait like 3 minutes? And I can sit them in like 3 minutes? Is that okay? Okay, thanks. And when we're done, if you can go to the office, okay? With after notes. Oh, he's not in trouble. All right. All right. A prime, B prime, 0, -8. C prime, 8, -4.
No way.
D prime is 4, 4. And E prime is 4, 8. All right. You'll notice when I connect E prime to D prime, E prime and D prime correspond to E and D. What's the length of ED?
1.
What's the length of E prime, D prime?
1.
What was the scale factor?
1.
Okay. Not only that, but when you look, as you're connecting your lines, if we used nice straight lines, what do you notice about BC and B prime, C prime? Same slope, which means they are
Similar.
parallel lines, parallel segments, yes. But they do have the same slope, parallel lines. So when we create these similar figures, we get all kinds of cool stuff happening in terms of parallel lines, which we'll find more out about later. Next.
You got the same parallel lines as both of them.
That's a day now. All right, one more, ladies and gentlemen. One more. Ladies and gentlemen, we have a scale factor of 3/4. Is this going to be a reduction or an enlargement? Reduction. How do you know? It's less than 1.
Excuse me.
So we do have a reduction. And we have some points here, O, P, and Q. What are the coordinates for O?
0, -4.
0, -4. P?
0.
40Q.
Negative 8.
Negative 8. Very good. And we have a scale factor, which means we're going to do a dilation. And we're going to multiply each coordinate by 3/4. 3/4 times x and 3/4 times y. Again, you can totally use a calculator. All right. So, O turns into what?
0, negative 3.
0, negative 3. How do we get negative 3? 3 times. Negative 4 times 3/4. This is negative 4 over 1. You multiply straight across. Negative 4 times 3 is negative 12. 4 times 1 is 4. And negative 12 over 4 is negative 3. Easy peasy. P prime turns into
Negative 6, 6.
3.
Oh, so my
Zero.
calculator.
No, we're talking about. We were talking about P, not Q.
And Q.
Oh, I did it out of order.
Q is negative 6, 6. How do we get negative 6?
I put it on my
You
calculator.
use your calculator?
Yeah.
Right. Negative 8 times 3/4.
Sorry, guys. My numbers are.
You go straight across, and we get negative 24 over 4, which is negative 6. All right, so this is a reduction, just a little bit here. So 0, negative 3, that's the O prime. 3, 0 is the P prime. And negative 6, 6, Q prime. Which is kind of cool. This could be like a cool, like, superhero emblem. I think so. I think it looks cool.
What is that? Triangle man?
Triangle man. Yeah. Okay. Ladies and gentlemen, how do you tell if something is a enlargement?
It gets bigger.
Okay. Scale factor is bigger than 1, and if it's a reduction,
Lower than 1.
less than 1. Scale factor less than 1. All right, ladies and gentlemen, you have adult math to do.
Yeah.